Imagine an individual who is paralyzed or have limited mobility in moving his or her arms and legs and falls and doesn't have access to an alert button. Smart Rescue is a technology that comes to the rescue. Rescue is a technology that lets users call for help with the use of their voice. Basically, it is a device that recognizes speech and sends email alerts to people, notifying them of a dangerous situation. Smart Rescue helps a paralyzed user live more independently and provides a sense of normalcy for them. ESP8266 board is a Wi-Fi enabled microprocessor unit that allows mounting of speech recognizer module. It also allows connection to the internet for sending email alerts. The Groove Speech Recognizer is a module that recognizes user speech to trigger the Wi-Fi module to send an email alert. We would also need some couple of wires to make connections between the Wi-Fi controller and the speech recognizer module. Combining the components together, we came up with a freeze design of Smart Rescue.
My name is Michael. In this video, I'll be discussing the setup, coding, and performance of Smart Rescue. This project requires an ESP8266 board to enable Smart Rescue internet connection, which allows the email alert function. To set up this project, we had to install this board on the Arduino IDE by going to File, Preferences, and inserting the board manager URL here, as you can see. Then going further to Tools, Board, and clicking on Board Manager to install ESP8266 board, which allows the various types of board to show here. And in this project, the specific board that was used was Lolin Wemos D1R2. Going further, I'd like to explain the codes in this project. The code in this project performs three main functions, which are connecting to the internet, reading and interpretation of user speech, and finally sending an email alert. So before then, I would like to also talk about the three major libraries that was used in this project. The first one is the email sender library, which allows sending an email to the provided email address. The second one is the ESP8266 library, which allows connection to the internet. And the third one is the software serial library, which allows serial communication between the ESP8266 board and the voice module. Here, the variable was declared for connection of the voice module to the board. So going further, this aspect of this code is a declaration of voice commands in array, which could be recognized by Smart Rescue. And also, here are the variable that was declared for connection of Smart Rescue to the internet, the network ID, and the password. Email sender. Email sender is a function which was actually used to specify the sender of the email to the provided email. To enable this function, to enable this email to be able to send an email to the provided email addresses, we had to activate a functionality in the Gmail account, which would allow less secure apps to send email. Void setup. This code here makes the device to get ready to exchange, to send data at a rate of 9600, and also be able to receive input. Void loop. The code here check if data is received from the voice module, the speech recognizer module. Then it reads the input from the speech recognizer module, and this code here outputs the input of which command is being said by users. So if command equals to 20, it should perform a mode 1 function, which is a function that's declared here when when mode 1 is being said by user. The device connects to the internet using this code to connect to the internet, and checks if it is connected. If not, it delays by 500 and continue to try to reconnect. If it's connected, it shows Wi-Fi connected and echoes the local IP. So after it's connected to the internet, then it sends an email message. Here is declaration of variable to hold the message. Here is the subject of the email. Here is the message that will be sent to the recipient, and here is the function that actually sends the email to the recipient, specifying the email address of the recipient and also the message to be sent. Here is the code that outputs the status of the email, if it was successfully sent or not. Moving on to how we set it up. To develop SmartRescue device, a Wi-Fi enabled board was used to allow connection to the internet, which precisely where MOSDIL and R2 was used in this project. A speech recognizer module was used for voice command, and also 4 jumper wires to enable connection of the speech recognizer module to the board, and also this also to connect the speech recognizer module to the board, and a USB cable to allow to power the board. So I'll be connecting this to the voice recognition module. Black jumper wire and the red, the green and the blue. The red jumper wire is connected to 3 volts to be able to power the speech recognizer module, and also the black jumper wire is connected to ground, while the green is connected to the RX and the blue is connected to the CX. Now I'm connecting the USB cable to power the board, and also connecting this to the system. As you can see, the board is working. Now moving on to testing SmartRescue device to see how it works. As you can see, the last email I have here is Coursera. Hi, cell. Mode 1. I should receive an email from SmartRescue. This is an email that was sent by SmartRescue. Opening the email says, SmartRescue alert. This is to notify you that the sender needs your help as they might be in a dangerous situation.
Our Smart Rescue project started by creating a meeting link via Discord, and the first meeting was held on 13th of January 2021. Series of meetings we held with long conversations through voice channel. We agreed to research on several Arduino ideas, and at the end of our research, we concluded to work on Smart Rescue. We created mirror board to facilitate the process of our project. We considered the requirements such as Arduino board to be used, voice command module, processing involved. After this, we shared the task and the project commenced. During this project, we encountered limitations and challenges such as We discover smart rescue can only work with internet. That is, if the internet is poor and or there is no internet at all in user environment, it cannot be used. The high cell prompt statement before connecting is also a limitation. During this project, the greatest challenges we had is with Wi-Fi module. We tried several ones such as ESP8260. It didn't work with Arduino. ATM mega generated ESP826 also, it did not give us desired results. We decided to research online and find out which board has been used by people for such tasks and consider the review. We discover Wemo's D1 RPS board. Wemo D1 RPS board has the greatest advantage in such a way that it's fast, efficient, and have direct support from the manufacturer if there is any problem or any challenges generated during the installation. For our smart rescue project, these are the future updates. We want a personally developed speech recognizer that will be able to recognize our own assets to overcome asset challenges. We also want the smart rescue to be able to give feedback to the user immediately after the message is delivered. We want smart rescue to be able to trigger emergency alarm to alert the environment or the neighbor if there is any happening. This is all about the future updates, the limitation, and our smart rescue. Thank you.